So once you finish the simulation, then you can I switch back to the dynamic simulation. There are some options here, and the most important one we're going to use is the output grapher. The output grapher is basically show you the result as indicated here. It can show you the plot of some variables. So you click this one, there will be a new window shown here. Let me move this link. So the window is divided into 3 sections. This one is a tree list. So there are joints, those are your joint, and there are also user variables. You can determine some variables later. And also reference frames. We won't use reference frames for now. Also traces, we'll explain those later. But let me show you a quick result. For example, if I want to know the movement of this light blue slider, I know there is a joint that's, we set a joint. Let me move here. I know the joint planar number 4 is indicating the motion between this blue one and this brown one. So basically this joint is telling me the motion of this blue, the motion between this blue one and the brown one. But because the brown one is a grounded link, so if I can determine the motion of this planar joint, then I can know the motion of this blue link. So anyway, let's move to this planar. There's a plus sign here. You can just click it, and it will show you a lot of variables. There are positions, velocity, and accelerations. We won't need force and moment for now. So you can just click this one. So there are 3 variables here, P2, P1, 2, 3. 1, 2, 3 means because it's in position. So that means the position in the 1 direction, 2 direction, and the 3rd direction. What does this mean? This basically means the X and Y and Z. But for now, you probably don't know, well, I don't know what's the X, Y, and Z. Well, there's a X, Y, Z here, but this X, Y, Z is different from the 1, 2, 3 here. If you want to know what exactly is the direction 1, direction 2, and direction 3, you go back to check this joint. Let me move forward. You will see when you click this one, there will be some vectors here. This one with 1 arrowhead, that means the 1 direction 1. This one with a double arrowhead, this one is direction 2, and this one is direction 3. So we want to know the movement of this blue slider, but we do know the blue slider will only move in the 3rd direction, the direction with the triple arrowhead. So I should click this one. So here you can see a plot. It's showing with the increase of the time, the position of the slider will be in this way. So you can see this animation. When you drag this animation bar, there will also be an indicator here to tell you what's the current position. So initially, it starts from minus, I think it's around 75, or as the time increased, it's moving backward, so the value is reducing. And until a certain moment, is moving back, moving up, moving to the positive value, and so this indicates the motion of this slider. And you can also go for the velocity. Let me cancel the position first. And if you check the V3, it will show you the velocity of this slider. So when the input is 120 degree per second, then the motion, the velocity of this light blue slider will be in this way. So you can also try other joints, and let's say I can also observe the movement of this pink one, the light pink one, and go to the velocity. And because right now we don't know what the direction 1, 2, 3 means, so you check the planar 7, which determine the orientation of this joint. So 1 is in this direction, 2 and 3 in this direction. So again, we know what we want is the third direction. So click this one, and then it will show you the velocity of this slider. You can also try 2 and 1, but you will see it will just be 0. Here, though, I think there's some calculation error, but anyway, the Y label are all labeled with 0, so that means there's no movement. No movement in the other two directions. There's only movement in this, the third direction. And you can also observe the motion of the revolute joint. So let me take a look of the position for revolute joint, because it's a 1 degree of freedom joint. Because for the sliding we use a planar joint, so the planar joint allow more, more degree of freedoms. So there are more options there. But for an arc joint, there is only one variable, which is the rotating angle, or the angular velocity, angular acceleration. So for position, you can see that's the position of this this linkage. It starts from 90 degree and goes to 90 plus 360, so it's 450 degree. And you can also see the velocity. Velocity is 120 degree per second. So that's it. That's very fundamental for the kinematic analysis of this mechanism. And you can use this dynamic simulation, this output grapher, to see the result easily. You just check the value you like. So you can also check the acceleration, but because it's a constant angular velocity, so the acceleration is going to be 0.